To recap the valid patterns of inference, and those are the only well-formed ones we know, we have the ones in the left column from the predicate logic, the valid patterns, all A's or B's, X is an A, therefore X is B. We're going from left to right, so to speak, in the positive direction. Then we have the one going in the negative direction, from right to left, all A's are B's, X is not a B, therefore X is not an A. Then we have all A's are B's, all B's are C's, therefore all A's are C's. And then we have, those three have analogs with if-thens. We'll talk about those in a second. Have no A's are B's, X is an A, therefore X is not a B. Those are our four predicate logic patterns that we focused on, that we know are well-formed, are valid. Now looking at the propositional logic, we know that there are corresponding kinds of inferences with if-then for our first three in predicate logic, and those are modus ponens, that is, if P then Q, P therefore Q. Modus tollens, that's going in the negative direction, if P then Q, not P, therefore, not Q, therefore not P. And hypothetical syllogism, the final analogous inference, if P then Q, if Q then R, therefore if P then R. And you can use for the if-thens the President Obama, that is, if the president is in the White House, then he's in Washington D.C., which will get you through modus ponens and modus tollens and make it clear. And for hypothetical syllogism, you just have to add the R, which is the president is in the United States. Okay, we knew about this, in addition to which, about the either-or inference, disjunctive syllogism, either P or Q, not P, therefore it has to be Q. And then we knew about contraposition, that is, if P then Q, if not Q, then not P. And by the way, the same rule, you can get the same rule going in the other direction, that is, if not Q, then not P, implies, you can conclude from that, if P then Q. That is, you can reverse the premise and conclusion. That's another form of contraposition. Then you have equivalence, P if and only if Q, not P, therefore not Q. And simplification, P and Q, therefore P. So that was kind of our world of valid inferences. We know that there are more valid inferences than that, but those are the ones we really have been focusing in on, and we've proved are good ones. Well, with that said, we're now going to turn to the idea of inductive logic. Those were the deductive patterns of arguments. But consider the following argument. We'll see why we need this inductive form. Almost all logic students did well on the test. John is a logic student, therefore John did well on the test. Well, let's say we know those two premises. Almost all logic students did well on the test, and John's a logic student. Looks like a good argument, Not 100% for the conclusion, which is what some of you guys are thinking. But even think about it, is if all you know about the situation is just almost all logic students did well on the test, and the only thing you know is that John is a logic student, you don't know anything about whether he was prepared or anything else, it's reasonable for you to conclude that John did well on the test. That is, so if you knew that the premises were true, would you have a good reason for thinking the conclusion's true? Sure. Does it guarantee the truth? No, but you still have a good reason for thinking it. However, so the answer is yes, there is a well-formed connection between the premises and conclusion. However, is the argument valid? And if we want to go back, it's almost all A's are B's, X is an A, therefore X is a B, we didn't have any valid patterns. We had one with all, but not with almost all, and it's really very different. And we'll see why in a second.